Hey, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at S3, and this is an introductory lecture, so we're calling this lecture S3 101. So what is S3? Well, S3 basically just stands for Simple Storage Service. So it's three S's, and that's why it's called S3. And S3 is one of the longest serving AWS services. It's been around for a very, very long time, since about 2006 or 2007. Now, because of that, it comes up on the exams an awful lot. It's in the Certified Cloud Practitioner exam, it's in the 3 associate exams, it's in the 2 professional exams, comes up in the specialties all the time. S3 is one of the most fundamental services for AWS. So what is it and what does it actually do? Well, the official Amazon definition is that it provides developers and IT teams with secure, durable, highly scalable object storage. It's easy to use with a simple web services interface to store and retrieve any amount of data anywhere on the web. So what does it actually mean? S3 is basically a place to put your files. It's a place to put your flat files. So things like videos, things like text files, things like pictures, basically any kind of flat file. And by flat file, I just mean a file that doesn't change. So you couldn't store a database file on S3 because a database file is always changing. But if it's a flat file like a picture or a video, for example, that's already been encoded, then it is a perfect candidate for S3. So what is S3? It's basically just a safe place to store your files, and it's referred to as object-based storage. So object-based storage is opposite to block-based storage in that object-based storage is a place to store your files, whereas block-based storage is where you would install an operating system or where you would install a database, etc. You don't want to install an operating system on S3. It doesn't work like that, but it is a perfect place to store your files. And the data is spread across multiple devices and multiple facilities. And the basics of S3 are as follows. It's object-based, so it allows you to upload files. Your files can be from 0 bytes all the way up to 5 terabytes in size. There's unlimited storage, and files are stored in buckets. Now, I know what you're thinking, buckets sounds a little bit weird, but I want you to think of a bucket as just a folder in the cloud. So just like when you use Windows Explorer or Finder on Mac, you create different folders to put different files in. That's all a bucket is. A bucket is a folder in the cloud. And buckets basically share a universal namespace, and that just means that their name must be unique globally. So if you try and register the bucket A Cloud Guru, it's taken. If you try and get test bucket, somebody probably took that back in 2006, 2007, that's taken. So you must make sure your bucket is a unique name globally. And this is the example of what a URL looks like for a bucket. So it always starts with S3, so that's the service, and then the region in which your bucket is located. So in this example, it's EU West 1, which is in Ireland, then .amazonaws.com, and then / and then the bucket name. And because it is creating a DNS entry or a website URL, that's why this bucket name must be unique globally. And when you upload a file to S3, you're always going to receive a HTTP 200 code if the upload was successful. It's really important to understand that going into your exam because that's the way you can test whether or not an upload has been successful. Now, S3 is object-based, and I want you to think of objects just as files. That's all they are. And objects consist of the following. So they consist of a key, and this is simply the name of the object. So it could be myworddocument.doc, or it could be mypicture.jpg. Then we have the value, and this is simply the data that is basically makes up the object. So it's made up of a sequence of bytes. So S3 is a key value store. You've got a key, which is the file name, and then the value, which is the actual data. You have a whole bunch of other things around it. So you have a version ID, which is important for versioning. We're going to come on to that as we go. We've got metadata. Metadata is just simply data about data that you are storing. And then we have some sub-resources. We have access control lists, and then we have a torrent. But the main thing going into your exam is to understand that S3 is simply a key value store. You've got your key, which is the object, the name of the object or the file name, and then the value, which is the actual data. And so how does data consistency for S3 work? And this is actually a really important exam topic as well. So we have two things. We have a read after write consistency for puts of new objects, and then we have eventual consistency for overwrite puts and deletes, and this can take some time to propagate. Now, don't worry if that sounds like it's in another language. I'll explain exactly what it means. It really did take me a long time to get my head around it, but it is such a fundamental topic that you will be tested on. You need to understand what it means. So let's start with the first one. If you are writing a new file, which is basically you're putting a new file into S3, and then you read it immediately afterwards, you're going to be able to view that data. So if I upload a file that just says hello cloudgurus.txt, as soon as I upload that, I'll immediately be able to read that data. So that's puts of new objects. If you update an existing file or you delete a file, basically you may reach the older version. So if I have upload a new file called Hello Cloud Gurus, and in it says Hello Cloud Gurus 2, and then I go to immediately access that afterwards, I might be reading the new file or I might be reading the old file. And the reason for that is it can take some time for objects to propagate amongst S3. Likewise, if I delete a file and then try and read it immediately afterwards, I still may be able to access that file. So that's all this means. Read after write consistency for puts of new objects. So you can, if you put a new file into S3, you will be immediately able to read it straight away after putting it into S3. But with eventual consistencies for overwrite puts and deletes, overwrite put means we're just overwriting an existing file, and delete means we're obviously deleting a file. So you only get eventual consistency for that. So it can take some time to propagate. So if you read a file after you've updated it, or if you read it immediately after deleting it, can take a few seconds for those changes to take effect. That's all this means. It's really, really simple. So S3 has the following guarantees from Amazon. It's built for 99.99% availability. So if you were to take out the number of seconds in any given month and multiply that by 99.99%, that's the availability that Amazon have built the platform for. Now, Amazon will actually only guarantee 99.9% availability. So if you take the number of seconds in a month and multiply it by 99.9, that's what Amazon will guarantee. But Amazon do guarantee, it's basically 99.99999. I'm not going to read it all out. We call it the 11 nines in the industry, and this is durability. So if you put a file up into S3, it's very unlikely that you're going to lose that file. Durability is simply the durability of the file. So, S3 hopefully won't go down. You won't lose access to that file. So it's guaranteed 11 nines durability. It is actually an awful lot higher than this from what I understand, but Amazon guarantee 11 nines durability. So you will not lose that file when you upload it to S3. And S3 has the following features. So you get tiered storage, which we'll cover off in a second. You get lifecycle management. So you can put a file up into S3, and then over a period of time, you can basically manage which storage tier it goes into. We have versioning. This allows you to do version control on your files. So if somebody overwrites a file and you didn't authorize it, or they made a mistake, you can restore to a previous version. We'll cover that off later on as well. It offers encryption, so you can encrypt your files at rest. And then you can secure your data using access control lists and bucket policies. Now, an access control list is just, it's on an individual file basis. So you can say, hey, this is called payroll.xls, so it's a payroll spreadsheet. I only want my payroll administrator to be able to access that. So access control lists work on an individual file or object level. And then we have bucket policies, and they work across entire buckets. So you could say, deny public access to this bucket, only allow my internal staff to be able to use it. So an access control list is on a file level, a bucket policy is on a bucket level. And then we have the different storage classes, and this has just changed as of reInvent 2018. There's now 6 different storage classes. So we've got S3 standard. This is the oldest storage class. This is the one with 99.99% availability, 11 nines durability, and it's stored redundantly across multiple devices in multiple facilities. And it's actually designed to sustain the loss of 2 facilities concurrently. We then have S3 infrequently accessed. This is for data that's accessed less frequently but requires a rapid access when needed. This is a lower fee than S3, but you are going to be charged a retrieval fee. So basically, this would be for data that you don't really access. Maybe you only access it once every 2-3 months, but you need, when you do want to access it, you need to be able to access it within milliseconds. We then have S3 one zone infrequently accessed. This is when you want the really, really low cost option and you do not require multiple availability zones. And we then have S3 intelligent tiering. This is the newest tiering of S3, and it actually uses machine learning, and it looks at your usage patterns, and it optimizes your costs by moving data to the most cost-effective access tier without any kind of performance impact or operational overhead. So S3 intelligent tiering could move your data between S3 standard, S3 infrequently accessed, etc., etc. So it uses machine learning to move your data across the different tiers. And then finally, we have Glacier. So we've got 2 different types of Glacier. We've got S3 Glacier, which is just a secure, durable, and low-cost storage class for data archiving. So this is where you can store any amounts of data at costs that are very competitive with, or even cheaper than on-premise solutions. And your retrieval time is configurable depending on what you want, and it ranges from minutes to hours. And then we have S3 S3 Glacier Deep Archive, and this is the lowest storage class available for AWS, and it's where retrieval time of 12 hours is acceptable. So basically you put it into Deep Archive, but when you want to go and access that data, you accept that you won't be able to get it for 12 hours from when you first make the request. So those are our 6 different storage classes that are available. If you go over to Amazon's website and have a look in the S3 storage tiers section, I'll put a link in the description in the resources section, you will be able to see this graph. You can see 11.9s. It's been designed for 11.9s for all of the storage classes. The availability does vary depending on the storage class. The availability SLA also varies, and then you can see the number of availability zones. It's always 3 or more availability zones apart from S3 one zone IA. And note down at the very bottom, the first byte latency. This means how quickly will you be able to access the first byte. It's in milliseconds for the first 4. With S3 Glacier, we're going to be between minutes or hours, and then with Deep Archive, we're going to be 12 hours or more. And in terms of the way you're charged for S3, you charge in the following ways. So you charge for storage, you charge on a per gig basis, you charge for the number of requests, you also charge on the storage management pricing, you charge for data transfer pricing, you're charged for if you use transfer acceleration and if you use cross-region replication. So let's have a look at what transfer acceleration is and what cross-region replication is. So what is S3 transfer acceleration? Well, basically it enables the fast, easy, and secure transfers of files over long distances between your end users and an S3 bucket. And basically it takes advantage of CloudFront's globally distributed edge locations. As the data arrives at an edge location, it's routed to Amazon S3 over an optimized network path. It's actually using Amazon's own backbone network. So how does this work in person? Well, let's say we've got our users and they're all around the world and they want to upload a file to our bucket, which is hosted in London. What will happen is if you enable transfer acceleration, those users will actually upload the buckets to an edge location that's nearest to them. The edge location will then use Amazon's really super fast network and it will upload it directly to the S3 bucket over Amazon's own internal network. It's at that point not traversing the general internet, it's going over Amazon's internal network from the edge location to the bucket location. So what's cross-region replication? Well, this is even easier. Let's say we have a bucket in the United States and we've got a user who uploads a file to that bucket. That file will automatically be generated or replicated over to another region. So in this case, it will go over to the Sydney region. So that's all cross-region replication is. It allows you to have 2 buckets, and every time someone uploads a file to your primary bucket, that file is going to be replicated to your secondary bucket, so you've got some disaster recovery. So we are at the end of this lecture. What are my exam tips? Well, just remember that S3 is object-based, and it allows you to upload files. Your files can be 0 bytes to 5 terabytes in size. There's unlimited storage. Files are stored in buckets. A bucket is simply a folder in the cloud. S3 is a universal namespace, so that means that bucket names must be unique globally. You cannot have the same bucket name as somebody else. An example of a bucket will always be S3 followed by the region, so EU West 1 in this one, then .amazonaws.com, and then / and the bucket name. It's important to be able to recognize these links going into your exam. Moving on, it is object-based, so it's not suitable to install an operating system on or to install a database on. When you do upload an object, you're going to get a HTTP 200 status code, which means the upload has been successful. The key fundamentals of S3, basically it's a key value pair. So the key is simply the name of the object, and then the value is simply the data, and it's made up of a sequence of bytes. In terms of the model for S3, every time you upload a new file or put a new file into S3, you're going to be able to read that object immediately. But if you are editing a file, so if you're uploading a new file that overwrites a file or you're deleting a file, that can take some time to propagate. So if you try and access that file immediately after uploading an object that overwrites it, or if you've deleted an object, that can take up to a second to propagate. So if you immediately read that file, you might get the older version, you might get the newer version. It really just depends. And then just remember the 6 different storage classes. So we've got S3 standard, we've got S3 infrequently accessed, we've got S3 one zone infrequently accessed, so this is where you want a lower cost solution but you don't need multiple availability zones. We then have S3 intelligent tiering. This uses machine learning to move your data around the different storage classes. We then have S3 Glacier. This is a secure, durable, low cost storage class for data archiving, and your retrieval times are always configurable between minutes to hours. And then if you want the lowest cost storage available, we've got Glacier Deep Archive, and this is where a retrieval time of 12 hours is acceptable. So that is it for S3. That's it for the theory side. As always, the best way to learn anything is to go ahead and get our hands dirty. So in the next lecture, we're going to start creating S3 buckets. I'm going to start uploading files to our S3 buckets. So if you've got the time, please join me in the next lecture. Thank you.